All right, welcome back to Serverless Office Hours. My name is Eric Johnson, EDJ Geek, on some socials, not on others. I don't even know which ones anymore. But with me, I have a couple folks now. Here we go. Are you ready? I told you I was going to work through this. All right, Vandana,
Oh, you got that.
Venkatesan.
Venkatesan, correct.
Oh man! Okay, I'm not going to say it all the whole hour now because I got it right. So, all right, okay, and then ready for this? Alex Vladimirov.
Perfect.
Did I roll my R's properly?
Yep.
What's up, man? I'm a man of the world right here. Hey, I'm super glad to have y'all here. We're going to be talking about modernizing e-commerce using serverless EDA. But before we jump into that, I want to get just tell us who you are. I'm going to start with you, Vandana. Tell us who you are at AWS, what you do, and your favorite pizza. Surprise.
um, my name is Vandana Venkatesan. I'm the senior go-to-market specialist supporting serverless for US West customers. And I've been at AWS for a year and change now. It's been exciting. Serverless is the way to go. I come from like an on-prem background, and serverless was like perfect for me to get into
Yeah.
and build my skills on. So, and my favorite pizza, I would say pineapple and jalapeno. I'm a
Oh,
vegetarian,
knock
Oh,
it
so
that's
off.
nice.
No way. Did you just say pineapple and
yes,
what was the
for
other one?
sure, jalapeno.
All right. Well, thanks for joining the show. We're gonna have to take her off now. So no, I'm just kidding. I don't know if you may not know this, but I have this long-standing live battle. I don't think pineapple should be anywhere near pizza, and I'm not even going to talk about the jalapenos. So, all right, Alex, tell us about who you are, what you do, and what's your favorite pizza.
My name is Alex Vladimirov. I'm a senior serverless solutions architect. I have been with AWS for almost 5 years now. Definitely enjoy serverless technologies. I'm based in Southern California, Irvine, and my favorite
Nice.
pizza is shrimp with garlic.
Okay, all right, that works. I'm okay with that. I pepperoni black olive and sausage. I approve of that. But you know, to each his own. I'm gonna let you have the pizza you want there, but we will discuss this later. I promise you. All right. Well, we got some folks coming in. Hey, what's up, squad? Luigi 64128. Welcome. If you're watching, this is a show we do every week. It's called Serverless Office Hours, and here's how it rolls. We talk. We're going to give you some information. Specifically today, we're going to be talking about e-commerce. But because it's an office hours, we can talk about a lot of different things. So ask us questions. You can ask us questions, but we're only going to answer serverless questions because you don't want me talking about VPCs for goodness sakes. So we'll give you Alex on that one. But we do this every week. So I want to kind of jump in real quick. Modernizing e-commerce using serverless EDA. Now, two things are real quick. If you're new to this channel or if you're new to these technologies, we're actually talking about kind of two different things. They work hand in hand. The first is EDA. Now, Alex, I'm going to let you kind of tell us what does EDA mean and how do you define EDA?
EDA means event-driven architectures, and event-driven architectures approach where you publish and subscribe to events and choreograph your work across multiple microservices in just simple terms. And the main benefits here, you use asynchronous processing, and that's what we're pretty much going to talk about today.
Yeah, excellent. And Vendana, darn it. Oh, I'm working. Vendana, serverless. If you did a quick elevator pitch, what is serverless for you?
Serverless is just the fact that I don't need to manage the infrastructure,
Yeah.
and the infrastructure is invisible to me. It doesn't exist as far as I'm concerned, the consumer is concerned, and AWS manages all that in the background, does all the patching and updates and the latest hardware and everything. And I only pay for the resources that I end up using,
That's right.
nothing more
Yeah.
than that. So.
Yeah, that's right. It's the managed services and you chain those together. That's exactly right. And so the cool thing is, while we didn't invent EDA here at AWS, we definitely made it easier, right? We made with the serverless technologies and the ability, and Alex, I like how you said it in simple terms. I'll tell you how I do EDA simple. Are you ready? If you want to write this down, you can. Here is EDA explained simply. Ready? Something happens and we respond. There you go. Event-driven architecture. And that's really the crux of what we're talking about, is this idea of, rather than me polling and having to talk to a bunch of things with my code, I just kick out an event. And if anybody wants to know about it, they respond to that event. And we're going to get deeper into that on the technology in a little bit, but we're going to kind of, we'll climb into that. But let's talk about why, and Vandana, this is for you. Why are we talking about e-commerce and retail? Why now? What brings this up to you?
We had a certain huge event happening in 2020, right? It was a global event,
Yes,
shook the
we
world
did.
up. And
Yes.
even before that, things were trending towards online shopping, online buying. And it has just accelerated the event that happened in 2020, accelerated that. I think in 2022, like the total amount of sales that happened online was like over $1 trillion. So
Yeah.
retailers are really, really fast catching up to how do they get their digital commerce going. And that's the main reason we are talking about it today. How to do it. Retailers are thinking of moving their systems from monoliths to cloud, and how to do it right. It's
Yeah.
just that the volume of sales that come online now tend to overwhelm retailers, and we don't want their systems crashing. That leads to huge losses. So, we just want them to talk about the technologies, that cloud native technologies that will be appropriate to handle the peaks and troughs in the sales.
That's right. That's right. There's a little, it's kind of interesting. There's a little startup. I don't know if you've heard of it. It's called Amazon.com. And they do a lot of volume. Tongue in cheek, and I'm playing around, but Amazon.com is one of the, is the primary, example of how do you handle massive load at scale with redundancy, with reliability and things like that. And so we're going to be talking about today, and we have other ones. I know some of the patterns we're going to talk about today are patterns that Lego uses, right? And so a lot of large companies do a lot of large e-commerce. Obviously, they use the cloud, and they're moving away from this monolith to this event-driven architecture because there's a resilience built in. There's a distribution to it that allows you to distribute across multiple systems, so you have redundancy built in. But it can be complex, right? I wish it were like, boom, there you go. I'm just going to flip a switch and we're done. But there's some complexity, like anything you build. To get it right, you want to, there's some complexity in getting in that. So we're going to kind of jump into this. Now, one of the patterns that we talk about now, Alex, I'm going to have you kind of expand on this. When we talk EDA, we think synchronous versus asynchronous. So what does that mean?
Yeah, first thing, it's not versus, because let's be realistic, we cannot
Okay,
convert
fair.
everything synchronous that we do to asynchronous. Specifically, when we talk about e-commerce solution, when customers navigate through your store portal, they show like a list of products, categories, order history. All those things will be synchronous because you want to show information as fast as possible to your customers. But there are parts of solutions that can be converted to asynchronous processing for benefits, like when customer start checkout process, when customer starts return. All those things will not happen immediately. So you can easily convert them to asynchronous processing to get all those benefits, Eric, that you mentioned before. So usually, like the right system uses both of those approaches. But if you have an advantage of using asynchronous processing, please do. That's pretty much the main pitch that I'm going to say.
That's what we say. And I'm going to make sure I understood you right. You're saying asynchronous first, right? And then synchronous when you have to.
Asynchronous if you can, where it's applicable. Like, because again, it's not a silver bullet. As you're absolutely right, asynchronous, it's additional complexity. It's not, we used APIs for like decades now. Everyone familiar with APIs. And later today, I will show you a demo where, which I created pretty much to explain EDA to customers that are not familiar with this approach. Because sometimes it's not easy to understand like eventual consistency. It's not easy to understand how choreography works, where orchestration is a good fit as well, because yes, we talk about synchronous versus asynchronous, but we also can orchestrate, and where to use like step functions over like event bridge. All those questions need to be answered when we design our solutions.
Okay, great. All right, that makes sense. Now, I'm going to challenge you here real quick. So I was hearing, when you say synchronous and asynchronous, I'm not hearing the A, so I want to make sure that I'm understanding when you're saying asynchronous. Now, that's me because I'm deaf. I'm old. There it is. I'm going to lay that out there.
Oh, it's just
guy.
my pronunciation.
Yeah, but I love it. I love it. But yeah, I just want to make sure that we're clear on when asynchronous makes sense. And my general rule of thumb, if I had thumbs, I would do that. But you get what I'm saying. If my general rule of thumb is I tend to go asynchronous, but there's a place for synchronous. Right tool, right pattern for the right job, right?
Exactly.
Last thing your customer wants, and especially when they're making a credit card payment, is to see a wheel turning and you're waiting and you're wondering, and then you run it again. That's the worst, So we want to know, hey, I want to run this. I want to get a message back, say, hey, we got it. We're working on it, and we'll let you know when it's done or something like that. So that's one of the options that we take. But okay, so earlier I said there's some benefits to when you're building these examples, right? There's benefits to EDA that, like we're talking about. We kind of talked about what is EDA. Something happens, we react, right? And wow, I'm getting really fuzzy there. I'm not sure what's going on. There we go. Yeah, so it's my pandemic camera is finally going. No, I don't know anymore. So, but anyway, but let's get into some of the benefits that some of our customers are seeing. And Vandana, I want to ask you about this. Lego is using some of these patterns, and how are they seeing that work for them?
Actually, let's talk about why they decided to do that first.
Oh,
right?
yeah, that's better. Yeah, absolutely.
It's like they had a huge sales event. I think it was a Black Friday sales event sometime in 2017 or something. And they got such huge demand for their product, and they were like on-prem monolith architecture. And they had such huge demand that their system crashed for a whole 2 hours. You can imagine the sort of loss they might have, had during those types of outages, right? They just lost a whole bunch of customers. So that's when they decided they needed to move to the cloud and needed to have the scalability and resiliency that they needed for such peaks. Like on average, like when they have these huge sales events, it's actually their user traffic goes up by like 9 to 10 times. That's like huge, right? And they're having humongous amount of like events coming through, customers looking at their website. Just the website traffic increases, the orders placed increases. They need to be able to handle this like huge spike on one day, and then the next day it goes back down. Obviously, if they are on-prem, they cannot provision that sort of like capacity, which means that they'll end up paying for that all the time. That's when they decided that they wanted to go to a event-driven sort of solution, and they were actually one of the first users of EventBridge, our event EDA event broker product, right? So
right.
That's when they moved to like an event-driven kind of hub and spoke model, where their orders come in. When the customer places the order, it's an asynchronous. Alex explained it really well. It's an asynchronous kind of like response to the customer saying that, hey, we got your order, we are looking at it, go away. And then like everything else happens in the background, right? Like your inventory checking happens, your payment processing happens, everything happens. And each time something happens, the customer can be notified asynchronously. So it's not like the customer is waiting there for the wheel to spin, like you mentioned, and like waiting for the response. It's not a synchronous thing, which really frustrates customers. We can't have that happen, right? So we can't have the system crash either. So for example, if the system shipping system crashed in, let's say, crashed in the background, I think which happened to one of our customers, their tax accounting system or something crashed, and which is okay, because you know what? The order management system can still take orders, the checkout system can still take orders and respond to the customer. And meanwhile, the developers are working on fixing the tax system, and boom, when it's up and running, they can respond to the customer. So that's one of the reasons why Lego went to an event-driven architecture, to have this resiliency in their architecture, which kind of lends itself to any sort of failures that happen in any of the other microservices. So we all think that, hey, it's a microservice architecture, hence it's got to be resilient. Not true. All microservice-based architectures are not resilient. The event-driven architecture with the event broker hub and spoke model is like truly resilient, right, for systems like e-commerce systems.
Right, exactly. Sorry, I was blocked there for a minute. So yeah, no, you're exactly right. And what's interesting is this idea of So, and I talk about this pattern some, and I'm not going to steal your thunder, I promise, Alex. Because Alex is so hold in there. Alex is actually going to show some architectures and some patterns. But when we talk about this resiliency being built in, and you talk about these distributed systems, what we're not saying is, hey, we're going to give you a magic system that never goes down. That's not realistic. Our CTO, Werner Vogel's even said everything fails all the time. It happens. Things go down. At Amazon or at AWS, we build as to try to not have it go down, but as if it will. So we build in redundancy. We build in these ways to say, like you were saying, hey, our accounting system has gone down, but we can still take orders because they can stack up in a queue or on a bus or something like that. And then when we come back up, then we can start processing those. So we don't lose that data. And because they're distributed, if we have an incident in one area, this other area can keep cruising along, right? And so it's when you think about scaling now, all of us, our first websites were really, come on, we all did WordPress and only my mom read mine, right? So, but the idea of if that goes down, not losing any money, just kind of frustrated. But if your e-commerce system goes down, that's critical. That's jobs, right? So you want to build this in. And I love, by the way, that you said, hey, I got your request. We're processing it now. Go away. That sounds like a parental thing. Like you say to your kid, "Look, I got it. I heard you. Go away. I'll get back to you." I love that. As a parent of 5, I was like, "Oh yeah, that resonates." So very cool. Yeah. So yeah, Lego. You're right. Lego was one of the first to use EventBridge, the bus. Sheen Brazil's over there is doing a lot of really good work. He kind of led that charge, and they built some cool things, and I built some cool things with their product. There's a wall over there with all my, I'm 53 years old, but I still build Legos, and I'm okay with that. So thank you, Lego. I appreciate you, and keep building. So, okay. So Alex, we're going to, jump on here. So as you're starting to get ready, you have an architecture you're going to show us that we're going to look at. So I'm going to kind of turn it over to you and have you explain what you're doing. And then we'll be doing a demo in a little bit. Again, I challenge you to go ahead and if you have questions for us, throw them in here. I have no problem interrupting Alex as he's talking. So throw us your questions. We'll be glad to answer. Alex, I turn it over to you. And let me know when you want your screen up.
Yeah, I'm sharing my screen right now. So
all right, here it goes.
So what you can see on the screen here, this is a demo that I created to explain event-driven architectures to our customers. You can see there are different portals here. On the left side, I have storefront, which customers can use to navigate through a list of products and categories. They can see a list of previous orders. They can look at order details. So just basic e-commerce functionality here. On the right side, I have an admin portal where I can see all orders in flight. This is an internal portal for our team. And I also have warehouse portal, which my warehouse workers are using to actually pack products and ship them to the customer. So this is just front-end part. There are 3 different portals. And let's look at architecture, what happens behind the scenes. I use Amplify to host my solution. This is a single-page application, all 3 of them. I use Amplify framework as well for implementation. I use Amazon Cognito to authenticate users and control access to websites and also to backend APIs. And I have several microservices here. You can see I have checkout service. It's using API Gateway, our API management solution. And I have Lambda and DynamoDB. Lambda is our compute, and DynamoDB is our database. It's like key value store, very scalable. And I mentioned before that you cannot build a solution that's fully asynchronous. This API Gateway, Lambda, and DynamoDB, they provide synchronous APIs to support my website functionality. So when customers navigate through the portal, I want to retrieve data as fast as possible. So those requests synchronous. But as soon as customer starts checkout process, this Lambda here publishes an event that is going to EventBridge. Let's do it. So let me add several products to my cart. I want to add different ones so you'll get more interesting processing done. So I have my cart. I have some products there. I'm going to start.
That's a lot of money.
Yeah.
You and I are doing Christmas differently, buddy. A sassy watch, a swanky. I like that. Hey, we had a comment on here. It's kind of funny. It was the Half-Life. The Half-Life logo. Yeah, I have a Lambda. That's our Lambda. That was Lambda before it was Half-Life, just so you know. But yes, that looks similar.
Yep, I'm going to start checkout process now, and that's what just happened. I started a synchronous processing of this order. From customer side, what I can see, I can continue shopping because somebody already took my order and it's being processed, and I'm asynchronously getting notifications for changes of statuses for my order and for shipments. So if you get back to our diagram, what's happening here, this order created event got published when I started the checkout process, and event bridge routed it to my order service. You can see here I have SQS, it's our queue, and as Eric mentioned, this is one of our best practices to put queues in front of critical parts of your functionality for several reasons. Resilience is one of the main ones. Imagine I made mistake. I published broken code to my microservice, and it's no longer
That never
working.
happens. Yeah.
It might happen. As the result, processing fails. And I can imagine I'm sales event is coming, it's Black Friday or Cyber Monday, and I'm getting millions of orders. Not a big deal because all of those events will be temporarily stored in this queue for up to 14 days. And then as soon as I fix my problem and system is up and running, I will process all those events without losing any data. So this is the main reason why we strongly recommend to have queues in front of every critical parts of your system, and it gives me resilience. But in addition to resilience, I also can get load leveling. This is another pattern that is very useful. Imagine I'm using DynamoDB here, and it's very scalable. But imagine I need to use relational database like RDS, our relational database service, because I have some other systems that using relational databases. Obviously, relational databases cannot scale as fast as the rest of this architecture. I do need to protect those systems from being overwhelmed, and I can control the pace with which I process those events. Our Lambda event source mapping configuration with SQSQ allow me to specify how many Lambdas in parallel will be processing those messages. So I can, for example, specify I don't want more than 100 or 500 of Lambdas processing those messages. So I will keep my relational database healthy. It will not get slow because I can control the pace, and still all my events eventually get processed and I will not lose any data. So both resilience and load leveling will give me will make my solution just way more resilient than if I try to build the same thing using APIs. Another benefit here with APIs.
Hey, Alex, I'm gonna interrupt you for a sec. So real quick, so I know you're on a groove. Sorry. So remember where you are, but couple things real quick. So SQS, you're doing load balancing, and I think you clarified right at the end. As that queue is just going to fill up with data, right? Okay. So it's something important to understand. I think Alex pointed it out, but I want to make sure it's clearly understood. Is the Lambda functions can handle the capacity, right? In Lambda, we can handle 1,000 concurrent invocations, not per second, concurrent. All right, so that's a ton, and that's out of the box. We can upgrade that. So he's not protecting the Lambda service, but he is protecting, and a lot of us will have, we have these kind of applications where we have these legacy systems downstream that just can't handle the load, and we haven't been able to upgrade them. So the queue is a really good place to put that, but you don't lose data. It continues, and the amount of traffic it can handle, I love on the documented amount on the docs is, if you read the docs, is virtually unlimited. I love that. So it can handle just massive amounts of traffic, and this is kind of the magic behind some of our Cyber Mondays and different things like that. So great pattern. What's that? Yeah, Prime Day, exactly. Now I'm going to step you back for a minute. You referred to Amplify a couple of times. What does Amplify do?
Yeah, so from Amplify here, this Amplify can do multiple things. In my case, I'm using Amplify as a hosting. Imagine you need to host single page application. Common approach will be to put your website on S3 bucket and kind of make it public. You can make it available for CloudFront as well, but it's manual work. It's still very good pattern. Many customers are using it, but instead of following that approach, you can use Amplify console. You can point it to your GitHub repository. It will automatically grab your code, compile it, and publish it, and make it available for your customers automatically. So just very convenient service to host your applications, specifically single page applications, something that JavaScript based, in my case, I'm using React with TypeScript, but Amplify hosting is very convenient service, just, to make your life easier and remove all that heavy lifting. I also use Amplify framework. This is another thing. It's part of your solution. In my case, Amplify framework allow me to integrate with Cognita, with AppSync, and some other services here, just so I don't need to write all that code myself. So like,
Yeah,
but those are two different things. Like Amplify, like hosting, and Amplify framework. Like framework is a library. Hosting is like our service that we offer to host applications.
Yeah. So yeah. Thanks for pointing that out. I wanted to kind of give that out. We've got a couple of questions coming in. I'm going to do them a little out of order, but I'm not forgetting you. Okay. So one of the questions we have is this one. I guess DLQ is just omitted on the schema. Do you have DLQs built in here?
Obviously, yes,
okay,
and actually in multiple places. You're absolutely right. I omitted, like diagram is already complex.
So much, exactly.
Yeah, so I omitted several things just for simplicity, because this is like displays only happy path, but there are a lot of DLQs here. By the way, DLQ obviously here, like if like I cannot process a message, it's like poison message. I have retry policy defined that will, after several attempts, will move it to that letter queue. Event bridge has its own queue, because when you create your rules for event bridge, you define your filter, like so you can select which events you want to route to specific target, and for each target, I also specify that letter queue. If like target is not available, maybe event bridge doesn't have permissions to, like, put a message to queue or something like that, it will not get lost, because it will go to its own that letter queue here. So yes, that letter queue is here, and within event bridge rules as well. So like it's like best practice. I strongly recommend to use that letter queues like everywhere.
Add another layer of resiliency, it looks like.
Yes,
that's right.
Because imagine like I cannot process a message, and it's something that I cannot automatically, recover from. Message goes to that letter queue, where I can like see it, check what's wrong with it, maybe fix it, and push it back to the queue for processing. So that's
nice that Event Bridge has it built in as well.
Yep,
that's right. So, and if you're not familiar, DLQ stands for dead letter queue, and literally it's just an SQSQ that's for dead letters, things that didn't work, and then you could go and you can manually process them. You can set up an automated process, but this is that, like Vandana said, this is that resiliency being added. It's just another layer, and it's automated into the services. I don't have to code for it. I could just say, okay, I could set up some retries, try this 3 times, backing off. If it doesn't work, dump it in a DLQ, move on. And then at that point we can say, and notify me, or not me, because hopefully I'm not the one that has to get up at 2 a.m, but notify somebody. So yeah, great point. We have a question on managing large architecture. Leon hate OAS. I don't know exactly what that is, but this is something we're going to get back to. I'm definitely going to kind of grill Alex on it in a few minutes, and Vandana and get their opinions. So don't think I'm ignoring your question. Alex, I'm going to let you continue explaining. I think you were on to step 3 here.
Yep. Yeah. So as I started explaining, after we published order created event and it got routed to order service, you can see I have a small workflow here. Obviously, I can code all those steps within single Lambda function. Many customers do, but there are services that can make it easier for you. I'm using step function express workflow here. I'm using express workflows because it helps me to orchestrate a solution that's very scalable offering that we have, but it can run for up to 5 minutes. In my case, I expect all those steps to be completed within 5 minutes. That's why I express workflow here. But if in your case you have very maybe integration with your legacy system, or maybe with third-party solution that takes longer than 5 minutes, you can use standard workflow and run them for up to a year. So again, there are flexibility here, but if you have a workflow that you want to implement, we strongly encourage you to use step function express or standard to orchestrate all those steps. Just makes your life easier, and it's very visual. It's supports a lot of different integrations. In my case, all of them lambdas, but it supports integration with other services as well. So we can easily add and remove steps when you need to. And after, during that workflow, I reserve items in different warehouses. I have 4 virtual warehouses for this solution, just to emulate more complex processing, process payments, create shipments, and I may have more than one shipment for the order, depending on how many warehouses will be involved to deliver products to the customer. And when all those steps successfully done, I publish another event, which is order processed event, which goes to 2 places. It goes to fulfillment service, but it also goes to this interesting notification service. But you can see here, I have Lambda function and I have IoT core. If you're familiar with solution that Eric and his team built, Serverless Espresso, you can see I have t-shirts with it.
Yeah, that's right.
They also use IoT core. This is one of options that how you can use WebSockets on AWS. You can use API gateway, you can use IoT core, you can use AppSync. In my case, I use IoT Core because it's very simple service to allow like WebSocket connections to your backend. And I'm using WebSockets to update my user interfaces every time when like I need to notify customers or my internal teams about some updates with like order statuses or shipment statuses. So in my case, event get routed to both notification service, so UI is getting updated, and I see updates like this here asynchronously. Like, remember, we talked about good customer experience. Customer published an order, and we asynchronously update customers using WebSockets, or we can use pinpoint here to send email, SMS, or mobile push notification. So those asynchronous updates will make our customers informed about like things that change and happens behind the scenes, and at the same time they can continue like shopping for like other products. So good customer experience overall.
Yeah.
But when we also get this business event routed to fulfillment service, what is happening here, I create pick lists. Pick lists is something that my warehouse workers will be using to actually pack specific products to the boxes and ship them to the customers. And that's actually interesting pattern is happening here. I mentioned before that I may have more than one shipment generated for an order. So what's happening here is fan-out implementation of event-driven architecture. I generate multiple, sometimes one or more shipment-prepared events that getting routed to my warehouse service. And the reason this is, I have multiple events because I want to process those orders in parallel. Because imagine I have 3 or 4 warehouses involved to ship all those products to the customer. There is no reason for them to process those like events like one after another. I can process them in parallel. So what will happen? Each warehouse worker in different warehouse will get its own shipment to process and send it. So if we get back to our user interface, I simplified this approach. So like I have kind of one warehouse worker processing those shipments, so I can demonstrate all of it. But the same thing can happen on multiple user interfaces. I can show you like iPad that will get the same events to process. Yeah. So what I've got here, I've got one order, I've got 3 shipments generated for this order, and I have 3 shipments to process as warehouse worker. So at the moment, we on step here. One more thing to add. I mentioned before, I'm using API Gateway for REST APIs, but another option is AppSync. It's GraphQL managed service that we offer to our customers. So you can create GraphQL queries to request data from your multiple like backend systems. In my case, it's DynamoDB. And also it supports subscriptions. So the same WebSockets integrations that allow you to notify your user interface in case something changed on your backend system. So in my case, when event is getting published to warehouse service, UI is getting event here through subscriptions, through AppSync subscriptions, and those shipments automatically pops up on the user interface. I don't need to refresh my screen to like check if I have new shipments to process or not. So that's another benefit of using AppSync here. AppSync supports disconnected scenarios. Imagine my warehouse worker with tablet like walks into the part of the warehouse where like connection for Wi-Fi is unstable or like not available at all. They can still update their user interface. They can change statuses, and then when they get back to connection, they can synchronize those changes with the cloud and get all those updates in the cloud available. So like AppSync here is like natural feed because of like both GraphQL and subscriptions. Okay, let's continue processing. Let's imagine I'm like warehouse worker. I'm getting a product, scan it with barcode scanner and put it in the box. So that's what I'm doing here. I'm going to ship this box to the customer. As soon as I did it, you can see there are several changes happened. First thing, I've got 1 shipment processed, 2 still in progress. Customer got notified that like 1 shipment was processed, and I can check what's happening there. This is my order. 2 shipments still in prepared status, but 1 is processed. I have my tracking number that I can use to track delivery of the product to me. So part of the order is processed. But let's get back to diagram. What happened here? As soon as I ship this shipment, I publish shipment processed event that got routed back to fulfillment service here. And this Lambda here, what it's doing, it's checking, was this latest shipment for this order or not? Because it was not, it just ignores this event. That's how you implement fan-out with event-driven architectures. You need to process all those events, and you need to check, like, if, like, in my case, I have like 3 events generated for 1 order. I need to check for all those events, was it the latest event or not, before I can complete the processing of the whole order. Let me go back and finish processing here. So I'm going to process the rest of those shipments. We can still see orders in processing status. And let me process the final shipment. And you can see as soon as it's processed, our order is fulfilled. And customer can see that, yeah, everything was shipped to me. So getting back to diagram, our last shipment went back to fulfillment service. This Lambda checked, okay, it was latest shipment. I'm completing this order and let customer know that order is processed. They can wait for their item to be arriving soon. So that's how this whole event flow looks like.
Hey, Alex,
Yep.
I'm going to take Eric's job for a bit and ask both of you a
Yeah.
question.
Jump in.
To both of you. Eric, I think Alex mentioned that he's using both the synchronous pattern in this checkout service as well as like asynchronous patterns in this architecture. So question for both of you, in addition to using synchronous and asynchronous patterns, looks like there's both event bridge, which does the choreography, and step functions, which does the orchestration. So that seems like that's another pattern that's used quite a bit together,
Yeah.
right?
Yeah, So I'm sorry, Alex, I jumped in here, but we I'm not sorry. That's a big fat lie. So yeah, so we talk about choreography and orchestration, right? Alex's app is a beautiful example of how this works, and he's got them kind of segmented out, right? You have your checkout service, you have your notification service, you have your fulfillment service, you have your order service, and so on, and you're choreographing events across those domains, right? Or across these services. So we need a way to do that. And you kind of see that event bridge as a central hub, right? And then the next thing we're doing is inside we're orchestrating, because remember what Alex was saying is I don't need this warehouse sitting while these warehouses are working. Okay, we're done. Now you start yours. That doesn't make sense. We want this parallel idea going on, but we have to orchestrate that. We have to say who's doing what, right? So using step functions, we have this logic to say this has to happen, then this has to happen, or all these things can happen at the same time, but they need to be done over here, right? So there's a choreography between the domains, and there's an orchestration that kind of controls that inside, and these combined make an extremely powerful and resilient kind of workshop here, or kind of architecture. We do have some questions coming in. So Alex, we're going to take a few moments if you're all right. So I'm going to go back. I'm going to ask this question real quick here, and then we're going to go back to one asked earlier. Blue Abs asks, is this an example arc for warehouse egress? Doesn't look like it applies to DCs. What are your thoughts on that?
What is DCs?
Data centers, I'm assuming.
Oh,
Yeah,
yeah. So, so the idea, think about this solution overall. Yes, I'm hosting everything in the cloud. I use like serverless here, but you can easily replace all those components with whatever technologies you prefer to use. If you don't use Event Bridge, or don't use RabbitMQ, for example, at the moment, because it's what your company prefers. You can use it. It's the same like event router. You can publish and subscribe to events and choreograph your work the same way. If you cannot use Lambda for some reason, or maybe you have other solutions that like running on EC2 or containers, or maybe on-prem, nothing stopping you from receiving those events, processing them, and publishing them back. You don't want to use DynamoDB, you can use relational database, document database, like nothing stopping you. You can replace all those components with other technologies and hosting them on-prem as well if you really want. Warehouse service can be on-prem. Nothing stopping you to subscribe to events from the cloud and publishing them back to the cloud. And still, idea stays the same. Choreography stays the same. You can still control your flow when you process your orders. And so this solution can be hosted anywhere you want.
Yeah, and applied to any number of things. And I kind of understand what Blue Abs is saying is this looks more like, is this a distribution center? Yeah, this can be applied to distribution center. We might need to extend it and stuff, but this area over here, yeah. Okay, I'm not presenting a screen, but I'm showing you with my mouse. The fulfillment service got to be the distribution center area that can that can be that can
Yeah,
work
and
out
usually
better. So,
what you can, obviously I emulate some of those, like we mentioned, reserve items. This will work with probably your warehouse solution to, like, reserve items in specific warehouse. Processing payment, there probably will be some third-party processing payment system that you will integrate here. It still will not change the flow. And like the reason why I used a function here is because I can easily add and remove steps depending on your processing. This is very simple one, but like customers usually use way more complex workflows here. And they like obviously will be more than one workflow. In my case, it's just happy path for order processing. But imagine I'm trying to process a payment and credit card that customers provided to you is expired. So you can stop right here, send notification to the customer, like please update your credit card information, and you just wait until information is updated. When customers update credit card information, another event is published. You react on this event and try to reprocess this order again using newly provided credit card information, and then continue processing. Obviously, this is like just displays happy path, but you can easily add more and more flows that to support your business needs. Idea stays the same.
And the pattern makes it easier to add stuff as well, because now we're not having to go back to code and insert lines of code and existing code. We're just simply subscribing to events, right? And so, oh, hey, you know what? I need to do some more. I need to use a generative AI solution to summarize some stuff. I throw out an event and I subscribe to that. Okay, I'm going to go back to the question I avoided earlier because it's kind of a bigger topic, but it's a great question. And this is what was asked: is I've used Serverless DynamoDB, Lambdas, and AppSync for an e-commerce site. It is fun, but after a time, it stopped being manageable. As the features you want to put in increases, the number of Lambdas increase. What is your suggestion on this problem? And I have some ideas, but I'll let you all speak to this first if you'd like, and then we can come around to it.
Yeah, obvious idea, you do have to use infrastructure as a code approach. Like there are a lot of ways how you can do it. Customers love Terraform, serverless framework, CDK, AWS. For this specific solution, I use CDK because it's like pretty complex and I want to organize my code in a way that I can easily manageable. For example, I can deploy this whole solution to my cloud environment with just one line of one request, or I can deploy all those components separately. So I have control. Yeah. In this way, I can give like each of those services to separate teams in my organization if that service became complex, and they can manage it separately. With all of those components, they loosely coupled. They're not like monolithic. So I don't have to deploy all of them at once. I can deploy them separately. I can update them separately. As long as I don't change schema for my events, nothing will get broken. Like similar idea with APIs. Like as long as you keep your API the same, you can change internal implementation without affecting the rest of your solution. Yeah. So use good infrastructure as a code solution. If you try to manage it directly in the cloud or update it manually, it will not fly. And it's the same for any solution. It's not only about Lambdas and other components. Lambdas just make your life easier that you don't need to manage infrastructure. So you can think about Lambda just part of your business logic. But when you create your solution as Docker, for example, you still need to be sure that you're writing code properly, because you may end up with spaghetti code everywhere and end up with the same problem. It's hard to manage, hard to maintain, hard to introduce additional features. So in my case, it's just more visual because all those components separately, but real solution, regardless of technology you use, will look the same. It may be hidden kind of within your container or within your Java or .NET application, but still good organization of your code, good organization of your DevOps pipeline will help you to manage all of that.
That's right.
This
I agree.
decoupling is a thing of beauty, right? It's really like this decoupling lends itself to so many benefits. Like your teams can be more agile because, like Alex mentioned, you have separate teams working on different microservices, and then it all comes together because you have the central hub of Event Broker, which receives and passes events. So like Alex said, good organization, upfront planning, we have event storming sessions, all that helps as well.
Yeah. And I would throw, so I'd get a little more granular as well. You both great advice. One of the things, when we first started talking about service, and I did the same thing, is we originally is okay, for every method and for every resource and method on an API, it's a separate Lambda, right? So for gets, it's a Lambda function. I said Lambda without function. Chris Munn's freaking out right now. So for a Lambda function, right? So for gets, it's one Lambda function. For posts, it's another Lambda function. For deletes, it's another Lambda function. And that works. It's an absolutely viable, scalable, incredibly reliable system. But you're right. It becomes kind of a management nightmare and headache. So again, like they were saying, infrastructure as code, and you could infrastructure as code. Eric Johnson, you'll see a billion videos out there of me saying use infrastructure as code, and I absolutely agree with you. But the other thing is logically plan out what you're doing. You don't have to have a Lambda function. We push against doing what we call monolithic Lambda functions, where basically we're just taking these monoliths and you got a million lines of code in one Lambda function. But you can do logical grouping. Right? Look, for this domain, we're going to have one Lambda function, because that doesn't mean it's not going to scale. You can't, because a lot of times we have a hard time separating yeah, but Eric, that's one computer. No. You don't think of it that's what. That Lambda function is still going to scale as you need it. It's just they're going to be calling the same code base repeatedly instead of different code bases based on what's happening. So I guess what I'm saying is kind of figure out the line of that domain and saying, this is where I'm going to break that down. Because in reality, and Alex, you said it well, but in reality, you have to do all this code anyway. If you were building in a monolith, in fact, it would be quite a bit more. We abstract a lot of that wiring together and security and throttling and caching and all that kind of stuff away. But you would have to manage all that code. So now instead of going, I'm going to do it in this Lambda function, I got to go, what line of code was that? I'm down to 349 million. I can't find it. So there's complexity either way. And we feel that this makes it a little easier. But I get where you're coming from. And hopefully that gives you some advice or some help on that. Okay, we have a couple things. Hang on a sec. A couple more questions coming in. So we have this. Back to okay. So EDA works well when we want to organize communication between backend services, but users want immediate responses for actions do not care the complexity of the task. So I think this is in reference when we're talking about WebSockets. I think so. It increases complexity of UI. We need two-directional communication. Alex has mentioned sockets and AppSync, so it is very important for the UX designer to understand the backend logic. Yes and no. And that sometimes that, in my opinion, sometimes that depends on the architecture you're using. For instance, if I'm using AppSync, I need to understand more about the data because I'm creating that contract at the client, right? I'm saying, because I'm using GraphQL, I'm saying what I want. But I get that AppSync, I get that synchronization out of the box, right? Whereas with REST API, the contract is defined at the API end. So I don't need to know much about that. Same with WebSockets. I can subscribe to a topic and then you just send me what you want. So yes, you need to have some understanding, but if it's well documented and well contracted, that should be good.
I agree. And also, I want to be honest, in my case, I use Amplify framework for that specific reason, because I can easily subscribe to WebSockets for it. Like pretty much all I do, I specify where my endpoint is for IT core, and then I can receive events from it. And then depending on the type of the event, I can run different logic. It's no different than I like invoke API. So like for UI designer, they don't need to understand how all that like backend system works. All they need to know, they eventually might get something from this specific endpoint and then can react on it and update their user interface. So I don't think it's like that complex. With GraphQL, I agree with Eric that like you do need to like understand how to make those queries, which is good and bad because it can save time for your developers. They can automatically retrieve data from a lot of different, backend systems.
And very granularly. So
yep, exactly. But there are a lot of benefits with GraphQL because you can request multiple things right away and retrieve like final result. With APIs, you usually make multiple calls to do the same thing. So, both technologies are good. It's like depending how your team is familiar with like either one. If they like REST, like API gateway is like good option. If they kind of enjoy GraphQL, it's also an awesome service. I use both just so customers will see they're both good fit.
Yeah, that was great. So I got a couple of questions coming in. First is this should be easy. Just take a second to answer this real quick, Alex. This is how would you design disaster recovery for this architecture? And go.
Okay, funny enough, this question is like, it's very popular across our customers. And
It's a great
the
question.
first
Yeah.
question I will ask from customer, like, what's your business requirements? Because when we talk about disaster recovery, every organization is different. We can go from like, let's just have some backup of our data in another region in case something happened. Within like few hours, we'll be back up online and support our business. And I want to be honest, majority of customers are totally fine with this approach. We have customers that say, no, like, should be zero downtime, and they go like active across multiple regions. And so first you need to understand your business requirements. When you understand them, let's talk about like this specific architecture. All of these components, and that's another benefits of serverless, you can easily deploy to multiple regions and you will not be paying anything, because unless there are like events to process, this architecture is free. But as soon as you start
dormant, yeah.
But as soon as you start getting events, it will scale up as like to whatever like amount of resources you need, and it will process all that like huge number of events for you. So building multi-region architectures with serverless, it's very easy. And also we always trying to help customers to make those architectures more convenient. Like for example, with DynamoDB, you can use global tables, which will spread across multiple regions and automatically keep them synchronized. So in case one region goes down, you can easily route your traffic to another region. No data will be lost. The only thing that I would recommend to avoid, I've seen some customers trying to do redundancy on like some interim components, like for example, SQS queues and other things. It may be very hard to keep those things synchronized across multiple regions. They're probably easier to just stick with synchronization on database level, either to use like global tables, Aurora supports like, the same functionality, but or send backups to another region, like also send S3 bucket like synchronization like across multiple regions, and rely on them to keep your data updated in like multiple destinations. So again, first, understand your business requirements. Second, use services that we provide to you. Don't try to reinvent the wheel. A lot of services that we offer, they're redundant. Some of them just operate in one region, but you can easily deploy them to multiple regions if you want.
That's right. And I'll throw this up there. This is great out about SVs and Boca. I think if you're using CDK, and basically the references use infrastructure as code. And the thing I would really encourage you to do is I should be able to deploy an application, and I love this that Alex was saying. I can deploy different parts of it, right? But that part I should be able to deploy it basically on a command. Right. It shouldn't be, okay, I have to deploy it and I have to go set these and then I have to chain this and I have to go figure out this stuff like that. The infrastructure as code is built in so that you can deploy all at once. So that there is that if you don't have a disaster recovery area, then, and I need to bring something up, then I'm changing. And for me, for all of my apps, it's generally as simple as changing my profile, because I have a profile tied to each region. Change my profile, same build, same deploy, or Terraform apply. I use both, or CDK. I use CDK. But the idea is a quick ability to deploy if it's not out there. So let me do a little housekeeping real quick here. Are these sessions recorded, available after the session? Absolutely. This happens every week. We do this on Tuesdays, and it's immediately available on YouTube and Twitch and LinkedIn. And I'll post the YouTube link here shortly. If you're watching it on YouTube, you already have it. Okay, so one more question here. Again, I'll give it to each of us here, and Alex, we may run out of time here. Is there anything you desperately want to show real quick?
No, I was planning to just emulate small like sales event, like with like we have hopefully like a large number of people watching this. So I wanted to just let them participate in the demo. So let's just make this like, let's do small load test of this solution. What you can see here, this is my admin portal where like, we can see orders in flight. This is my warehouse portal. So if you can scan these barcodes with your phone and like order several products for me, I want to see how the system performs under the load. So when you do it, you should be able, I'm not sure if you can see my screen, probably not. You should get access to the store.
Yeah,
where
you can see your phone as well.
Yeah, that's the idea that like you can see that the store, you can click on like plus like for specific products to add them to your cart. As soon as you do it, you should be able to see like semi-transparent cart item like checkout, and you can click on checkout and we should receive your order. And as soon as you start getting updates, you will see a small like bell icon that will show you like notifications. Like in my case, my order is getting processed and I'm getting notifications on my phone. So like you can see, like I started getting some orders. I expect there will be a lot of orders. I'll keep this thing open for like.
Yeah, they're all from me.
When are you shipping it out, Alex?
Yeah, I'm going to enable like automatic processing for this one. So we will just, eventually all of them will get processed. I don't want to manually do it. But if you get back
you
to
have
the
same day
screen,
shipping, yeah.
yep, you can see there are like I received some like orders here, and they keep coming in.
Yeah,
Yeah.
Get on it, Alex.
Yep. So what's happening here right now? Like we emulated like sales when customers just jumped, and started like ordering stuff. But at the same time, system will store information in queues, like in databases. So like there is no like component in the system that cannot handle the load. And that's like what we explain to our customers when we talk about event-driven architecture. Imagine I'm trying to make my environment ready like for a sales event and I'm using APIs. I need to like probably over provision, and still like I cannot estimate how many customers will try to order products. As a result, I may under provision, I'll get problems like APIs will be slow, customers will get bad experience, I may not be able to even process some orders, I will lose some money for my business. But with this approach, I don't need to worry about such things because solution can handle enormous amount of requests and I can control the pace with which I process them. So that's the main advantage here, and like pretty much, we just demonstrated it to you.
Okay, so I'm going to interrupt you there because we are running out of time, and I'm going to answer a couple of questions really quick. Real quick, we had the question: what is better, to use Apache VLT and it's VTL? And I'm just so I had corrected my head. And intrinsic functions and step functions, or to put logic into Lambda functions. Use the right tool. So I use, when I have actual business logic, then I'm going to use a Lambda function that's going to compute. Other than that, if I'm routing, I tend to use VTL and API Gateway, or step functions is my go-to because step functions has all direct integration. The next question we had is, I'll answer that in a minute. I want to answer this question. It says, this is nice and all, but now how would I do it? So I'm going to throw out a couple things, and then we're running out of time. You'll see my Twitter handle there, EDJ Geek. Please reach out to me, or send. Alex, do you have a Twitter that you use or a LinkedIn?
I do, but I don't post there much.
Okay,
so
that's all right. So hit me. I can connect. Vandana, do you have one? Do you want to advertise?
I don't, but LinkedIn is a good place to reach out to both of us.
LinkedIn was a good place. Yep.
Put your links in the chat and I'll share them with everybody. But I'm going to show this screen. So if you're enjoying this event-driven architecture, that's what we're talking about. How do I build architectures that can scale like this, like what Alex is showing? We actually do a thing called EDA Day. And this is happening in Nashville this year on October 26th. It's $99. And if you use Eric 10, that'll get you a 10% off. You can scan here. And we've got some of the biggest names in EDA speaking at this. We're going to be talking about David Boyne's going to be doing that. We have generative AI in event-driven architecture. We've got medical. Grant Lamy's talking about how they're helping to diagnose cancer using step functions and event-driven architecture. Super powerful. Jess Dean is going to be talking about containers and event-driven architecture. If you have a container orchestra, how do we do that? And we have a lot of the speakers. We have a cool keynote announcement coming next week. I highly encourage you to go to this. If you're in the Nashville area, it's worth a flight to go there. We did this in London last year. Tickets sold out, standing room only, and it was wildly popular. So that's one way. And you're like, okay, Eric, that's a shameless plug. A little bit. Let me give you the one that doesn't cost you to travel, but you're not going to get everything out of this. But one of the sites our team maintains this site called serverlessland.com. This is a good place to get started, to learn content, code, EDA. What is EDA? Give me more description. Help me understand, how do I do all that? Yeah. Grant Lamy's in the chat. Hey, I know that guy. What, the bald one? That's me, Grant. So anyway, but yeah, it's going to be some great streaming. We are not live streaming the event. We did get the question. However, they'll probably come out on GoTo. This is in conjunction with GoTo conferences. I can't talk. They pay me to talk here at AWS. It's frightening. So this is in conjunction with that. So last thing I'm going to do is I'm going to post a blog link that will take you to a blog. Alex, tell them about your blog, or Vandana, you want to tell them about it?
Yeah. Quickly, Alex and I go through this architecture and the benefits that you'll get from using this pattern. So the part one of the blog is just a high-level overview of the event flow that happens in this architecture and how you would choreograph and orchestrate the different microservices. So part two of the blog, Alex, I think, do you want to talk about it? You'll be publishing some code on GitHub.
Yes, so we are working. It will be like 3 parts for this blog post. Second one will contain source code for this solution, so you'll be able to deploy it to your own account and play with it and reuse components if you want. And the third part will also include some user interface, so you'll be able to also plug in those UI that I created with whatever backend you publish, and you can test the whole thing with like nice UI as well. So like we expect probably like within like somewhere by the end of the next month, we will get part 2 available. Excellent. And backend will be on AWS Samples GitHub.
Yeah, part one
Excellent.
is already available right now, so you can kind of like, browse through that and let us know if you have any feedback requests.
Yeah, excellent. Thank you so much, both of you, for being here. We are out of time. We've had a great show. Hopefully this helps. Please follow up with us if you want to know more information. Next week, we're going to be having a workshop on serverless patterns, right? And so we're going to be talking about, again, it's a continuation. When we say serverless, a lot of times it's synonymous with EDA. We're talking about patterns on how you start building these and putting these together at a more granular level. With that, I'm going to check us out. Thanks, Alex. Thanks, Vandana. I appreciate you being here, and we'll see you later. Thank you. And this is where